Welcome back to Wickerson Studios, and I am doing this series here, and I stayed focused on creating parametric points, creating parametric curves, and my main point, and I went on to some basic trigonometric curves, was to say why would you work parametrically instead of statically in Rhino? The real reason comes down to the fact that mathematics had to progress from algebra and geometry into predicting and assuming things are in relative motion towards one another with calculus. So this is not a boring lecture on calculus. It's actually a very exciting lecture on calculus. If I jump in here and show you my basic number sliders of t, and playing a bit with this, if I was to change with where the height was to start, you'd see the effect of dropping the ball off the end. And if I pulled that ball back to the top, you can see how it situates right here. I'm going to show you how to make this very simple model. I shouldn't have it set right to 0 because I'll lose my data, so I'm just going to go into here and bring this minimum up to 0.01, so I always have, so I don't have a 0. Basically throwing a ball off a cliff, and here's what it would do, and don't let it fool you when it gets down here that it would actually stop evenly on here, because it's not perfectly tangent to what's going on here. In fact, it might be. But I could always adjust the height and push that through. I could always not take it up to such a height and push it right through. So we're going to build this model, and I think you'll learn a lot in Grasshopper as we start modeling it. Something as essential as understanding what's going on here on a two-dimensional plane. Of course, there's other programs and other scripting methods, and I don't know why I'm not doing this in Jupyter Notebooks with Python and all these other things, but this is for the person that wants to get into Grasshopper. It's for that designer, that artist that always loved mathematics in school. And here it is. We're going to look at functions, limits, and continuity and ask what is calculus. And it's the analysis of relationships that change with time. Calculus measures the way, the way related quantities change. Maybe I'll fix up my stuff as I go. I apologize for spending your time on this, but why not catch the errors now? Just to show that this has been somewhat spontaneous today, the way related quantities change. And you can get into differentiation and integration. So you start thinking about what that means to the tangents to these points and going back and forth. So if you've been interested in that, addition and subtraction, just think about going into calculus and think of things as differentiating and integrating. We're going to stay with single, I think we're going to stay with single variable calculus for quite some time. I have a lot of other notes, and this file is going to build pretty darn big on what I'm doing. But let's just consider the motion of a falling rock. Let's consider the heights in meters and the rock t falling in seconds over time. And I'll fix this later. If I dropped it from a height 0, and I don't have the greatest, I think it's called like, what is that called in Python, or in Python that you could actually import a library and get these great functions. I'm not going to get into it. I'm just going to call h at 0, h at o, so I don't get into a digit. And the formula is going to be negative 4.9 t squared. So you're basically introducing the expression node, which is what I did in my last section on trigonometric curves. We're going to graph y at ht. And we're going to differentiation allows us to find a new function, h, change in t, and call the derivative with h with respect to t. And h prime a t, if you want to call it that, is going to end up equaling the velocity as opposed to the distance of this rock falling without any gravitational pull. So we're going to use minus 9.8 at t and end up times t. And this represents the rate of change. Oh, I should fix this. Sorry about that. Oh, maybe I'll go back and do my restart. But change of the height of the rock, its velocity in meters per second. So we're going to build this script and actually show you how to model something as interesting as this and how to get in here and grab your data, how to control it, how to write it out. It's not a terrible script to get into, but it is exciting enough to build from scratch. So what I'm going to do is probably take it all off and show you how to begin scripting this diagram. And it's not in 3 dimensions, so if you switched over to perspective, you'd see you're still working on a 2D plane. I guess it might be kind of nice to look at it as we build it in the perspective view. That might confuse people, but why not confuse people? So I'm going to take this all off and put it to preview off. I'm going to show you how to build it. And it's the same thing as where we went through before. I'm going to be constructing points. So I'll go into sets, into vectors. And I'm going to go in and grab constructing a point. And I'm going to want to construct here 3 points to begin with. 2, 3. And these points are going to help me label this chart. And they're all defaulting at 0, 0, 0 right now. And one nice thing to do is select it, center them, and space them so they're even. One thing I've been doing consistently through here is going into sets and going into range. And I'm going to grab 3 ranges. as well. And I'm going to put it through the number sliders of what I want, but I'm actually going to hard code the steps very high so I have a little bit of finesse. And you can do that by double clicking, putting in a quote, and type in, I'm going to use 48 as my count in each one of these in the ranges. So you'll pop that into all three of those because that's going to be essential. And then I'm going to set my domain to, I believe, up to 2 seconds. So I can have a nice line here. You'll see exactly why I'm doing this. I'm going to quote 2, and I get a nice little default here. You don't have to take it off multi-line data. You'll see a few people doing that. As they get into here, they'll go in here and say, okay, I'll right click and put it on multi-line data. You can just leave it as it is. Put that in as a domain. Cut and paste. Double click and change that value to 5 in the bottom one. And that we can put in the domain here. And what I'm going to do is bring in each one of these in. The step count here, I've still left a domain here, which we're going to end up using. I'm going to take that and put it into my X point. I'm going to make a nice little row of points here that I can make a line out of. This one I'm going to put into my Y coordinate, which is going to build this line that goes up in this direction. And I think I will go back to top view just not to confuse anybody. And so long as I've done this correctly, 2 in the top, 5 in the bottom, I'm actually going to take my 5 in the bottom to my Y. So I have a nice chart, X and Y, and I'll end up taking these off after I interpolate them. And then the next bit of data, which is fairly nice, is I'm going to need 2 number sliders. So one, I'm going to set up a number slider at, I'm going to push it a little bit above 1. I think I'll put it at 1 point. Well, if I'm going to specify what I want to do, I'm going to start at 0.01 ... 2, and we'll go 1.25 seconds. So that's a little tricky what I did there. And one thing to also do in here is I'm going to put on my edit snapping and have this set at 0.25, 0.5 seconds, 0.75 seconds, 1 second, and it'll go up to the 1.25. I don't want to have a space there. I'll hit enter, and now as I bring that along, you'll see it snaps at those numbers. Snap, snap. It always snaps on the ends, obviously, because there's nowhere to go, but we'll leave it at 0.25 seconds. And that's going to be, you can right-click and change that to your time. So we'll change it to T. And the other number slider, we're going to go up to 5. So we'll go from same thing, 0.01 to 5.00. And that will give us up to 5 height. And we will change that to the height. Where's the height at 0 as we go? I think that's what I'm going to end up doing it. Height at, and we'll use a small letter 0 for that. We're going to push that into the domain. And the first one we're going to push into, the domain's going to go up to 1, and the 5 is actually going to run into an equation. And here's where it's going to get interesting. So let's just take care of these curves to start with and go into curves and grab interpolated. Put those points through here so we can see it. And we'll interpolate the next one. We don't have to worry about the degrees and finesse on this because we put enough points in. And we can get rid of all these points as well so we don't see them. Preview off. And now we're seeing our 2 curves. So that's basically just how we got this, made this little tiny chart here, which is what I wanted. Now what we're going to do is build with this third point an equation. And the equation is going to come specifically from the text that we said above. And you can write notes from out of your calculus book directly into here. Go into the math tab. Go into the expression node. You're going to want to come in here and zoom in and right click and change this variable to time. And this one you're going to want to change the variable to O, which is actually representative of H at a small 0 at that point. And at that point, we can actually bring in our H and T. So we bring our T into, actually we want to bring in our range of T, and we want to have it go all the way up to 5. But it's not running yet because the script isn't written right. So now we have to write in the script that we want, which is going to be H at the small 0, which is minus 4.9 times, and then I'm actually going to put into here T to the exponent 2. So once you start playing with this, you'll end up getting some very nice geometries. We're going to hit OK, and that should run, and should give us an output of 49 points as we move through the Y in this section. So I'm going to be taking my range off of this one from my T with a little bit of finesse. And I'm going to put this one in here, and even though you can't see it, I will take it to an interpolated curve so we can visualize it. Cutting and pasting. And now you see our little tiny curve as it's going through the time of what's actually happening. The rest of this exercise is literally just trying to make an interesting thing to visualize as we go. So the rest of the script is fairly simple. So now I'm going to show you a little bit about using a 3D tag and how that works. This curve, I like to go into Curve Tools and use the midpoint. So I'll grab the midpoint of that curve because I'll need that. I will grab the midpoint of this other curve, and these are just positions where I want to put text. And then I also want to find the start and end points of this one because I want to do something at the end of that point. And actually, technically, I want to do something in the middle of this point, middle of this curve as well. So I'm going to take the middle of this curve right here. And now we have lots of things to start putting data at. And what I'm going to do is go into the 3D text tag. There it is. And I'm going to pull that up because I want to do 4 text tags. I want to do 4 text tags here. I'll show you exactly what I'm going to end up doing in it. Let's get them a little organized. I already know that I want the size of all of these to default to, what was it that I wanted to default to? Well, we definitely want to put our text into each one, but at the midpoint of this curve, the location, I'm going to want to put a text. I could hit panel, use that quote, and I think T was what I wanted to end up putting in there. So I'm going to take that little text tag, put it in there, and the size on all of these is going to put 0, 2 as a size. And that just works well for this scale of diagram. You can change that around if you're used to rescaling things. We're going to make all the text sizes about that big. Then we're going to have a panel. And this gets a little tricky here. This T is okay, but if you see where it is, it's not in a great position. So what I'm going to do is, let me just check up here what I ended up doing. I'm going to want a justification, set that to the point to be at the top right, or I could do top center. But if I'm going to do that, I'm going to double click, and you have to think of blank spaces. And this is just like working in any programming language. I put a space at the top so I could jog that T down a little bit. So that's a little technique of what I ended up doing. There's some cool things you can do on these panel tools when you zoom in and start playing with these 9 little squares, but I'm not going to worry about it. It just makes this panel tool read a little differently. The next one, I'm going to take this midpoint, and I want to put in the text Y, but I also, when I put that text in, Y, I want to leave some spaces behind it. And I'm going to leave that and put that in and see if that text is correct, but it's not justified. I'm going to put it at the right center, I believe so. You have to think of the object you're trying to put in there, right middle, and there it goes. It moves over a little bit. The next one is at the end of the point, which I'm going to leave. No, I'm going to put my HE in there, and I think doing so, let's H0, sorry. Let's see where it turns up to begin with if I put it in the location at the start. And there it is. It's not justified. We're going to put it at the right middle again, but we're going to go in here and put a few blank spaces at the end just to move it over. And that should allow us, as we move this time frame, it should be fine, but as we change the height, you'll see the HO changes along the Y. So I'm just literally visualizing things and having fun. And I hope this is for somebody that wants a little more front-end like displays, which I don't do very often. And then the last one, I'm going to take my midpoint and put it to this location, and my text size is actually going to be the equation of what I'm trying to display. So I'm going to go in here and quote, and I'm going to say Y is equal to H at T at that time. And that should be enough to throw in here as a text. And I've got that. The only thing I want to do is just do a little bit of fudging, which is, like I said, common to any programming language that you end up doing. And that, of course, will move with what's happening. All those can stay on visuals because those are fine. And the one thing I want to do now, which is interesting, is think back to those curves. I also want to do a little bit to make it funky. And I went in here and I hit down a curve offset. And I like that little tool. You could do offset both sides. I'm just going to do curve offset one side. Grab that first curve here. And I'm going to set a basic distance of what I want. And I think I defaulted to 0.1, but I'm going to be moving in the negative direction as well. So quote 0.1, enter. I can put that into the distance here. You'll see I move that line down. And I have that line, and I have the line where it came from. And of course, what I can do with that is fairly simple. Is flatten a loft, which a lot of people are used to. Bring a loft in, take both curves. So I'll want to take this curve, holding down shift. I'll want to take the interpolated curve, and I'll want to take the sorry, I'm losing my mind a little bit. The new curve that I just brought in. I'm just thinking a little bit my offset. Yeah, I want to bring my new curve in, which I didn't bring all the way over. That's why I'm losing my mind. Bring that one all the way over to the curve, and then we also want to hit shift and add that one, but make sure you flatten these two, otherwise it won't read them as two things on one list, and you'll get that nice little volume in between. Once you're done that, you can take off the edges, preview off, and there you go. You get that nice little bar that you can select. If my colors are different than yours, right click, hit preferences, and change these just by clicking on them. Right click and move whatever color around you want. I like mine dark blue and dark red, or sometimes mid blue and orange, but that's up to you to do. And I'm going to leave that. So now when I select it, goes that color. And then I'm also going to do the same thing again with the two other curves, but I want to throw in a little negative in this direction. Don't reverse your curve or make it negative or negative the curve. That's not going to make any sense. But if I pull this -1 in here and bring that in as a distance, what I can do is I can grab this curve and shift. That one was already in there. I made the same mistake before. Bring that one in, override the 2, and then shift edit that one in. You should have that curve. And there you go. The other thing I want to do, and this gets a little tricky, is at the end of this point, I can evaluate the curve. And if you're not used to starting with evaluating curve, I would suggest it's a great tool to begin with because you're going to be evaluating surfaces as you get three-dimensional. Evaluate that curve at the end point, and that will set you the end point of this curve. Evaluate curve. Did I evaluate curve? I believe I did. I'm a little curious. Oh, because I haven't set the parameter in. I'm going to set that parameter defaulting to the end of it because it's going to read 0 to 1, but it's also not going to read right until I reparameterize that curve. And there's something wrong here. Failed to go from point. I brought in the wrong thing. I want to bring the curve in, and I wanted to reparameterize it. There we go. It'll put you at the end of that point. But what's nice is it gives you the tangent. So once you have the tangent to that, you can just go into here in data visualization under this eye, hit display vectors, and take that vector, not only that point of where that is, you can take that and throw it in the direction of that. And beyond that point, we end up with this vector visualized. That's what we want. You can put an amplification in here through using math. And one little tool I like here is this special node called amplitude. So you can literally just take that vector, put it in here, and then hard code in a number, or have something like, let's say 0 to 2.4. And there we go. Now we can amplify that vector if we wanted to see it a little differently. Is it going to work? It's at 0 right now. Let's bring it out. So there's a count. There you go. You can visualize that vector and put it in whatever you want. I don't mind the default value. The other thing that the amplitude's really doing, just to think about it, is a multiplication. You can definitely take that vector, and what's nice is you can multiply that vector, and you can put in that same number slider there, and you can double your vector size right there. So that's up to you to use. I don't end up using that. I'm going to leave it out and just put in my vector for visualization. But just to make us recognize that that's the point where I want to think things are, what I'm going to do is go into curves, make a circle. I'm going to choose the same radius as here, and then I'm going to grab that point of where I want it to be at 0 and make that little area, and then go into surfaces and make it solid so I can visualize that. Once that's visualized, I don't need the curves around it. So you take off all this other stuff and hit off. Now I think we're pretty close to being done with that script. I don't think we need anything on here. We don't need to see these. I mean, you can see the data here. We've got the curves. I don't believe we need any of these on. Let's put those to preview off. And now we have a nice little unit that is parametric, just like I built above it. I can play off of the height of where I start throwing the ball off of Y. And then I can also, and this gets really funky when you start bringing it into 3 or more dimensions and as many equations as you want to bring in. So that's the basics of it. That's why I'm teaching you point, line. And if it isn't interesting enough, I'm going to take all these and get rid of them because I just made them because I'm quite happy with this script here. Let's do preview on, and there it is. And the problem is I set everything on, and that's not what I wanted to do. I just wanted to see a few things. Let's just jump back into it for a second. None of that is really necessary. Let me go back. And I believe I shouldn't have taken preview off. I should have just, I think what I'll do is get rid of this one and move this one up. Oh, this is always fun. I'm just gonna, nope. I'm just trying to cut corners here so I don't have to worry about it. But there we go. Our visualization is there. Cut this one. And we'll take this one back up into here, and it shows us exactly what we want. And what's a nice habit when you're opening and closing, and I'm glad I kind of did this, we'll group it. What's nice is when you try and you don't want it seen, take it really to disable. That way, when you do enable it again and select everything, the objects that you want to see, considering whether or not to use the only draw preview geometry, which is not what I do. This way, the ones that are actually been opened are actually sitting there and changed. You can always highlight over them to see specifically what each one means. So that's a nice thing to begin. Now, if this isn't making sense, this is exactly where I'm going. And you can imagine my equations are going to drive circles, hyperbolas, ellipses, and all these wonderful things with the same basic knowledge of what I'm doing. We will push 3 dimensions in time, but this whole text is based on a lot of the wonderful stuff that comes out of single variable calculus. And a lot of this you may just be intimidated by to see it, but that's what I'm building, is this massive script. Pretty much a 101, university calculus book, but in Grasshopper, and I think it will be a wonderful tool. I myself lacked the visualization tools in 1990, so if I had this, I'm sure I would have sat down and really enjoyed the power of what was being created at the time, which were the programs that led to things like Grasshopper. So I'm going to take this through, have a lot of fun. We've gone into creating points, creating parametric curves, creating basic trigonometric curves, and now I've shown a very fast example of a motion of a falling rock, which I think I will just jump in here and possibly, I've got a couple spelling errors to make as well. I'm just going to grab a quick copy of that. Okay, and then I'm going to pop this one down here and use the scribble tool, which I love so much, and go in here and keep your text running. Like, your Grasshopper scripts should be readable to those that want to take a look at them and know exactly what's happening. And I think this type of organization and logic of learning the tool can be pretty amazing for future careers and what you end up may doing with what you're doing. Anyway, thanks for your patience on that one. We're slowly working towards making parametric circles, and you can imagine I'm going to get into that in a little bit. I'll spend a little bit of time on the Cartesian plane and intervals, because we're all dealing with very finite intervals when we're looking at calculus to make sense of it. We don't want to drift off into nowhere. It's going to be a fun first chapter, and thanks very much for watching.